Our next speaker is Dr. Giovanni Staranghi, who will be presenting a new classification for macular atrophy.
Dear moderator, dear colleagues, first of all, I would like to thank the organizer for inviting me to share with you the new classification on macular atrophy. These are my disclosure. You know, the question is why we have no success in treatment geographic atrophy. One of the possibilities because, you know, we have not the right target or not the right drug. But the other possibility is that we intervene too late when the lesion is already gone. Now, because of that, a group of clinicians, basic scientists and engineers convened to try to find an agreement on the classification of atrophy. And I spoke on their behalf. So the first thing that we did was to analyze which is the best imaging modalities to identifying and classifying the geographic atrophy. And of course, we analyzed the color images and also the new color images like a multicolor or the LED confocal images, the OCT structural, the OCT-A, the green, blue, near-infrared, the quantified autofluorescence, and fluorescein and ECG. The group, you know, agreed, and you actually saw from Frank Holtz that autofluorescence is a good way to identifying different patterns of atrophy. Some of those are quite typical of some inherited disease. Also, it was suggested, of course, to you know, measure the size of geographic atrophy and also you know, to follow the increased size of the atrophy. And in fact, these are actually right now the typical you know, imaging modalities that is used in clinical trials. But of course, why ICG? ICG because if we want to differentiate geographic atrophy from late onset Stargardt disease, we can actually look at the central part of atrophy, and in particular in geographic atrophy related to AMD, we have an isofluorescent area in the center part, and actually in late onset Stargardt disease, we have a dark atrophy. This is actually also visible with the OCT-A, and in fact, the presence of huge alveolar layer vessels are quite very well visible in central area of atrophy in late onset Stargardt, comparing with no visualization in patients with GA, where the still some subtle layer or choriocapillary can mask the normal huge vessels. And that was demonstrated and confirmed by some histology from Jerry Luty, Joe Holyfield, and Joanna Seddon. But the group decided that if you want to see the early changes of AMD, we actually have to use the structural OCT. And because of that, many different images were used to identifying different areas of changes, like, for example, the artery transmission, the barcode, and so on. And based on that, we start to classifying, and we classify in 4 groups: the complete retinal pigment epithelium and outer retinal atrophy, or CRORA, the incomplete RPE and outer retinal atrophy, or IORA, the complete outer retinal atrophy, or CORA, and incomplete outer retinal atrophy, IORA. In the rest of my presentation, I will focus on CRORA and IORA because these 2 parts are published. So what is a CRORA? The CRORA is a region of hypertransmission at the structural OCT of at least 250 microns in diameter in any lateral dimension, zonal attenuation of disruption or disruption of a retinal pigment epithelium of at least 250 microns in diameter, and evidence of underlying photoreceptor degeneration. And these are confirmed by histology. And what about iRORA? It's a region of signal hypertransmission into the choroid. Typically, in the OCT is the barcode sign, a corresponding zone of attenuation of disruption of RPE and evidence of underlying photoreceptor degeneration. So in conclusion, longitudinal data are now required to quantify the implied risk of vision loss associated with these features. And of course, the CAM classification provides initial definition, but of course, we can actually have more data, and that could change the classification. Thank you.